Okay.
All right. Good afternoon, people joining from Europe. Good evening, people joining from the East, and good morning for people joining from West. Uh, Welcome to our webinar. And we have Alex here and myself, Palgun. So probably we'll wait probably 1 more minute before we start the webinar. I hope you guys are able to see our screen and you are able to see Alex and me clearly, hear us clearly. Good. Perfect. So by the time the others will join, so maybe a quick introduction. So today we have Alex here, who's a senior consultant at Process Flows GmbH, and he volunteered to also help us out in explaining the automotive architectural design. So today we'll be talking about more about the system architecture design. So he is also a certified ASPICE assessor, and we are very happy to have you, Alex. Maybe quick words from your side.
Yeah, thank you, Falcon, for the short introduction. So I will cover more or less the theoretical, but also the practical part. So with some insights from practice, and of course, Falcon then show us the simulation in the tool. And I'm happy to be here.
Sounds good. Perfect. Thank you so much, Alex. And a quick introduction from my side. So I am Palgun Upadhyaya. I am currently heading the operations at Carnic, and I'll also give a brief overview about Carnic, but I've been in this industry trying to develop this AI architecture solution, and I'm very excited to show what the tool has to offer you today. That's a short introduction from my side. And as the organizer, we also have Bhumika, who will manage all your questions. So feel free to, you know, ask questions in the Q&A session. So I'll also give you some do's and don'ts. And welcome, Bhumika, and also welcome all the participants. Perfect. So today's agenda. So we have a 1 hour time slot. So we want to cover as much as possible. Of course, the key insight being that we are going to look into the system architecture, both on what is expected from the process side and the standard side, and how can we utilize AI and make it better and make it much more easier and faster for the users. So in the quick agenda, we have a couple of slides about the organization. So we have a few slides about Carnic, few slides about process flows. Then we are going to jump into the challenges in the system architecture design. So what are the current challenges faced? So Alex is going to give us a brief overview of what he has seen, the different challenges that in the industry, what are the current challenges. And then we do a bit back and forth between the demo and the theory. So this is where we'll look into the tool, we'll see the demo, we'll also go back and then try to see some of the details about system architecture, the theoretical aspects, and maybe some of the use cases covered by AI, and finally some upcoming features for this particular tool, and then we jump into the Q&A session. In the meantime, at any point of time during the webinar, if you guys have any kind of questions, so what you can also do is there is a Q&A session that is already active. So you can go to that Q&A session, post your questions there, and also remember to, if somebody has already posted some questions, feel free to upvote those questions so that, Alex and myself can pick up the most important questions, of course, given the limitation of the time, and we'll try to cover as much as possible. So that's a bit about the Q&A session. Perfect. Without any more delay, so a quick introduction about Carnic itself. So Carnic Technologies GmbH, headquartered in Munich, and we also have an R&D center in India, Mysuru. So these are the two locations we are present. Our main mission is to, expedite security of the next gen vehicles through disruptive technologies and innovations to mainly make sure that the engineers, creative engineers like you, are equipped well enough with the tools so that you can develop things faster and easier. Two main business models. One is the product area and the other is the service area. I'll start quickly with the service area. So we mainly look into the cybersecurity part of it. We do cybersecurity analysis, cybersecurity training, cybersecurity verification, validation, cybersecurity development, and cybersecurity management. And a quick overview on the products, which is also a highlight of today's topic. So we have two main product decks in our portfolio. One is the carAISuite, which is the product that we are going to talk about, and the other one is a legacy product, which is carSecurity, which you can also find on our website as well. So carSecurity is a automotive cybersecurity process landscape tool, and carAISuite is the AI-based automotive engineering and compliance tool. Over to you, Alex, to introduce Process Fellows.
Okay, thanks, Falgun. Yeah, some short words also about Process Fellows. Maybe many of you knows us already from the context of automotive spies. So we are more or less very into automotive spies and in the whole industry, but not only automotive spies. So I would like to highlight here that we not only do automotive spies, but we also do like other topics like normal project management support. Also, we have the organizational change, what we support, and for example, also systems engineering, cybersecurity, and functional safety. Our headquarters is in Ebermannstadt, so located near or next to Vorheim, and all our experts are across Germany. So I come from Munich, I'm from the very south, and yeah, happy to be here. So we can continue, Fagun. Yeah, we have four main areas what we support. So we do, of course, assessments, also gap analysis, not only automotive spies, but also other topics. Then, of course, we have the consulting area, what we support here. We do some coaching of the team, some hands-on coaching, and then as well, we offer training. So that's our four main areas what we have. And like I said, in different areas, we're going to support you here. Okay. This is something I would like to talk about. So we have you can call it our own product. It's called Spice for Cars. It's a knowledge database, you can call. And here we integrated spice models and some knowledge nuggets from our practical point of view, from our experience. So we enlarged the spice model with some knowledge nuggets, and you can check it out. Here's the website, and it's for free. So please feel free to have a look at this one. And this is about it for the introduction part, let's say. So if you're interested in our trainings, here you have a brief overview of what kind of trainings are next. All of them are in the guaranteed state. So you can see we have some certified in-tax trainings here on the website in different kind of areas. So automotive spice, of course, but also, let's say, the hardware extension should be here. Yeah, the last course is the hardware engineering. So also this is something we offer.
Perfect. Thank you so much, Alex, for a quick introduction. So now to talk a bit about the challenges. So maybe, Alex, I would ask you a quick question. So what are the typical challenges that you have overseen, that you have overcome in your vast experience in the industry in system architecture design?
Yeah. So we come directly to the next topic. So it's increasing system complexity. It's not only that the systems are interdisciplinary, let's say software, hardware, mechanics. Nowadays, we also have the machine learning. You can call it machine learning architecture integrated. It's also the layers. So that's one of the most difficult tasks to talk to the people and supporting the projects on what kind of layer or let's say level are you operating. So this makes it more complex. And of course, if we have a look at changes, so if changes occur, it's sometimes difficult to see what kind of area are impacted. So the increasing system complexity is one topic what we face. Another one is that everything is going very fast and changes occur quite frequently. So we have agile iterations, for example. We have many customer feedback loops, what we need to cover. We have some regulatory updates as well. So our architecture needs to be fast to can handle some changes. So we need to investigate the changes. And of course, if the requirements are updated frequently, there is a risk of then, let's say, having outdated artifacts. Another issue, or let's say challenge, is the traceability. So traceability is not only a big topic in automotive spice, but should be, of course, also in the normal engineering life. So we need to make sure that the traceability is in place. And of course, if you have multiple layers, also this needs to be covered. And if it's not, let's say, really supported by the tool, then you need to have a lot of manual effort to maintain it. Yeah. Another problem is so that not only everything is, let's say, linked with the traceability point, but it needs to be, of course, consistent. So you need to match and link the right topics. Here, for example, interface mismatches, integration of some bottlenecks. These are some problems we see in the normal life. And this will then propagate to lower level. Another aspect is, if you take a look at the project itself, we have many toolchain breaks. So we have one tool for requirements, we have one tool for architecture, we have one tool for testing. So many different tool breaks. And of course, if you have a tool break, you need to make sure that traceability is also in place and information is transferred to the other tool. So this is something which also is challenging for the architectures.
Perfect. So Alex, thank you so much for sharing the challenges. So we have seen these challenges, and I'm sure most of you are also experiencing these challenges. So when we were working in this field, so these challenges came in as, bottlenecks in terms of course, time, cost, efforts, everything. So this is where, with the advent of AI, what we thought, how about using AI? Of course, when we say we use AI, it is not about replacing the engineers, but equipping the engineers with right tools and technology so that things can be done much more faster, much more efficient, and much more, let's say, creative as well. So this gave to the birth of the carAISuite. So this is where, to address most of these challenges, if not all of them. So what we have at the center is a carAISuite engine, which, in this particular webinar today. So what we will be looking at is, we give the input. So the project team has the input as system requirement. So they can give that system requirement as an input to the carAISuite engine. And as an output, you will get the system architecture along with a compliance report, which is a review report of what all points was covered in the architecture, what all are yet to be covered, what all has to be reviewed, etc. So using carAISuite tool, so the architecture generation itself, you can perform it in the AI way with a very reliable and quick result. So you can already have, the first versions out, and then you can start working around that. So that is the base technology behind the carAISuite way. Now let's quickly look into the demo of the tool itself. So this is a overview screen of the tool. So I'll quickly create a new project. So I will try to also explain all the other features in the meantime. So let's say for the architecture, we create a project name. So the tool accepts some project names, um, and then let's say folder structure. I mean, in the folder, you just choose your folder, whichever you want, and where you want to place your project. You can give a, ECU name. So today I'll be putting the adaptive cruise control ECU, and it accepts a small description. So for the sake of simplicity, I have a description which is ready. Um, so I've added that description. So here you can see that it talks about the adaptive cruise control ECU, which is an advanced driver assistance system, which mainly controls the automatical. So it automatically maintains a safe distance from the vehicle ahead while preserving the driver defined cruise control. So it has CAN or Ethernet communication. It also is ISO 26262 compliant and ASPICE compliant as well. So this is a high level description that I want to give for the tool to understand that this is an ACC system. So I go to the next screen, I choose the different work products. So here I choose the system, I choose the system architecture design, quite straightforward here. So I need to give the inputs now. So here, right now, for the sake of demo, I have prepared a system requirement which is in an Excel format. We'll also open that up and have a look at it. So I classify this as system requirement, I import the data, and I create the project. So this is how you upload your documents. So here you can upload more than one document. For the sake of simplicity, I created one system requirement document which has the ACC system requirement description over there, and I've uploaded that. But if you have supporting documents, so if you have, let's say, some other ECU description, communication interfaces, you can also add that. You can also classify them and add those details over here. And then then you will land up in the project explorer. So here you can see the progress. So initially when you upload the data, so the intelligent system there in the backend, we have different agents which will try to understand this data. They chunk the data and store it in the right way. So we use MongoDB to store the data. So here when I say MongoDB, it could be in your private cloud solution, or it could be inside your infrastructure itself. It doesn't mean that the LLM has the access to the data. LLM does not use this data to train itself. It is just stored so that we can process this information. So there are intelligent ways where we can process this information. So here on the left side of the screen, you can see what all documents you have input, and it is also grouped and classified based on how or what category it belongs to. So this is the system requirement. And let's go ahead and then start the generation. So here you can see that for the architecture, for the sake of this demo in the system architecture, we have context view, we have layered architecture, we have interface architecture, and we have functional architecture. We will talk about each of these architecture details a bit later. So what I will do now, I will go ahead and then start the generation of the work product. This will take around 15 minutes. So maybe in the meantime, what we can also do is we can have a quick look at the input, and then a bit about the theory part as well, which Alex is going to enlighten us about what is expected from the standard and from ASPICE in the system architecture. We will keep coming back to the system requirements time and again, but for the sake of simplicity, so this is how the system requirement looks like. So this is the same input document that I've fed to the engine. So here you can see that I've tried to keep the whole thing as minimal as possible. I know that many projects offer different kinds of system requirements, so there can be different templates. You can have different attributes. The tool is able to handle different attributes as well. So it has an intelligent system to decipher what each attributes are. So here you can see that there are section numbers. There are some unique IDs, a category, if it is a functional requirement, non-functional requirement, or is it just a heading, or is it just an information? And I have some description, and I have some states. So here I have different conditions. So I have some operating modes. I have some power supply related details, I have some microcontroller related details, I have some activation and deactivation conditions, I have some communication related stuff, object detection. So these are some high level requirements. So of course, this is not a complete set of ACC requirements. So for the sake of the demo, I have a few set of requirements. We will then come back to this input later during our webinar. So you can see that now the tool is trying to retrieve all the requirements and then try to analyze each of these requirements to generate the architecture. In the meantime, let's go back to the presentation. Over to you, Alex.
Okay, thanks, Falgun. Yeah, before we jump a little bit more into the tool and have a look how the use cases are handled, let's have a brief look about the history, or let's say the development. So
what do you want to do? Do you guys want to continue the VT? Because we may not need it.
Hello?
Okay.
Yeah.
So, good. So let's just only have a brief look at the history, because then the interesting part, of course, then comes later. But I just want to highlight, so 1968, we had something like the software crisis. So we had failures in large scale projects. And this was the first time they introduced the software engineering as an own discipline, let's say, at another conference. And also one of the key realization was that system complexity must be managed through structure and decomposition. So this was already back then in '68, one of the key messages they found out at the conferences. So this was one of the you can say more or less one of the starting points here for having the architecture more important in the whole development. Then we have, maybe many of you already know, so we have the PANAS modular design principles. So that's typically also one of the architecture goals you have, and when it comes to the definition of your architecture, that the architecture needs to be modular. So this was established in 1972 to control and handle the complexity. Then in 1987, we had the first military standards targeting, let's say, systems engineering. This was also then later one of the bases for well-known frameworks like Segman or DODAF. So this was the starting point of having, let's say, some frameworks for the architecture. As well, in 2005, most of you will know the UML language, but in 2005, the SysML was also introduced here. So SysML is an, let's say, enhancement of UML, so they extended it. For example, the requirements diagram came in place, the parametric modeling was there, and this was also the emerging of MBSE, model-based system engineering. Then we had, in 2008, the birth of the ISO 15288. So this is a standard talking about systems engineering and defining the systems engineering lifecycle processes. Okay, we can continue. So how is it looking nowadays? So this was more or less the past. So when you take a look at the 2020s to 2023, I was also active on some conferences there. So the trend was here to integrate the architecture more in the other disciplines, to have it more synchronized. And I know from this time back, most of the experts were talking about digital twins. So this was a very big topic to have the digital twins here in place. So the architecture is more synchronized. Then I would say roughly around 2023, it started with having some AI integration. So the AI should here support, for example, in coming up with some traceability support, with some automatic checkings. So these were, let's say, the first steps what we investigated with AI. And then have a brief look at the outlook. So experts and researchers, they're talking about having AI agents in place to really have then the, for example, the interface coordination, the architecture coordination in place, also the architecture generation itself, supporting of the variant management. So these are some topics what AI agents can help you with, and of course also provide some simulation approaches here. So we're not talking at the moment at just some better architecture documentation, what you might think of, but we also talk about really having some architecture ecosystems, so some functional ecosystems.
Perfect.
Okay.
Thank you so much, Alex, for enlightening us a bit about the past and the future as well. I'm sure all of us knew about the current standards, but it's good to know about the past. And as you mentioned about the AI agents, I think this is also a very key aspect where the AI is not just considered as a support system to, do an automation or a traceability check support, but nowadays AI can also generate architecture by giving in the valuable inputs, which we'll also see once the output is generated. Perfect.
Correct.
Moving on to the next slide, characteristics of modern architecture, Alex.
Yes. So how should a modern architecture look like, or let's say, what are the requirements to a modern architecture? So first of all, we need to have it more integrated. So architecture is managed across several levels. So we need here some more integration of the architecture into the other domains. So we do not have, let's say, hard cuts. We should have some fluent transitions and some good integrated knowledge sharing. Yeah, and this also, of course, supports then when it comes to changes in this case. So we will face then the decreasing of complexity and not having all the time single tools. So it should be more integrated. The other aspect is with having it more integrated, we can, of course, then also have a better traceability in place. This helps us to have the traceability established across several levels, across several domains. So it helps us to then get rid of the traceability overhead in this case. Also, the new architecture, the modern architecture, should be capable of supporting consistency checks, also supporting of having some verification already included in here. So the simulation part, for example, when we talk about digital twins, it should be already possible with the architecture itself to run some simulations on the architecture for later verification. When we talk about quality, for example, modern architecture tools, they should also emphasize, let's say, architecture templates, usage of architecture templates, also having some formal review workflows in place. This helps, of course, also the quality in this case, and increase the quality overall. And last but not least, but this is a trend we see for many, many years now, we should be more working model-based. So the model base is one of the key elements in the architecture to have it really, the information stored in the model and to enlarge the model in this case. Okay, back to you, Falgun.
Thank you so much, Alex. So I think just before we jump into the use cases, so let me have a quick look at the tool. So how far are we? So I think we are generating different views. So now if you can see here, I think the context view is generated, the interface view is generated, layered view, the layered view is generated, interface view is being generated. Perfect. So then maybe I think it'll take another couple of minutes to generate the other views. So then, Alex, we can start with your use cases. I'll go back to the slide. Yes, Alex, over to you.
Okay. So now let's talk about the use cases. So first use case would be that AI should help us to generate the architecture itself. So not only having it more, let's say, text-based and do some refinement, but here we really talk about some architecture generation. Of course, for that we need some good inputs. So we need to have the requirements in place. User stories, for example. So SC in this case stands for source code. So if we talk about software architecture, then we need to have maybe the source code also as input, let's say, or if we do some backwards refinement, let's call it like this. And AI should help us to then develop some components, some interfaces, some boundaries, some layered structures. So Falgun already showed us we have different viewpoints in this case. And best case, we then have also a supporting language. So talking about UML and SysML, so that it's have a good notation and we can use it for the whole project and for other domains. So this will then lead to some faster architecture generation, and of course reduce the manual effort. So Falgun, can we see how it looks like in the tool?
Perfect, definitely, Alex. So here, so just to recap, so maybe I'll just quickly go back to the screen again. So you mentioned about the inputs that we can give to the tool, and then what kind of architecture it provides, and also what kind of, let's say, languages it uses. So going back again, maybe we can also take a look at the input. So I think I should have it open. Yeah. So yes, so we can take input in the form of system requirements, in the form of, let's say, supporting documents in the form of stakeholder requirements. So currently we support, in this demo, we are supporting Excel output, but in the full version, you also have the support of PDF documents, Word documents. It can be in any format that is possible. If you want to hook this tool up into our existing tool chain itself, that is also possible, of course, with a small customization, of course. But we can also link this to, let's say, the standard tools like Doors or Polarian or CodeBeamer. If you want to link that up, that is also possible. So this is regarding the input part. Now, coming back to the output part, so what all we generate. So here you can see that as part of the demo, so we try to cover in terms of system architecture both the static and the dynamic versions of the architecture. So here you can see a context diagram. So we saw that the whole input is regarding the ACC system, adaptive cruise control system. Now this is the context diagram it has generated. So let me just make this a bit big so that it is visible. So here you can see that the tool was able to identify that this is a adaptive cruise control system. So it calls itself as an ACC system, and it could check all the different external entities. So when we are talking about the context diagram, you have different connections. So in the requirement, we also saw there are many requirements regarding the activation and deactivation condition, which mean that you would read a lot of data, different sensor data. So these are the different connections that are available. So you can see that the tool identified each of these components along with the connection. So it has the different connection mechanisms. So you can see the item flow direction, the different ports. Also, to answer your third point, Alex, here, so we also have the SysML format that is incorporated. So the tool is able to generate. So for the view part, we have incorporated the draw IO, but these files can also be integrated or imported back into any of your existing architecture. For example, if you're using EA architecture or anything, so you can also import these things. And let's say you just want the diagrams, we also have the PNGs also generated for this. So this is a high-level view of context diagram. Next, we have a functional architecture. This is a functional architecture. So let me zoom in a bit more. So here you can see that, oops, too much. Yeah, here you can see that the complete system requirement. After identifying the context, it also identified what is the functionality of the ACC system itself. So there are different software functions, there are different hardware functions, there are of course the interface functions. So here you can see that there needs to be a diagnostic manager, the ACC mode manager needs to be present. There are different sensor managements available. Along with that, so if you saw during the input, I also put in a context with respect to the description that this is also compliant to ISO 26262 and ASPICE. So when we talk about ISO 26262, there are some safety relevant artifacts. You must have realized that when I opened the system architecture, the system requirement, I did not specifically mention anything about the safety. Of course, if you have anything regarding the ASIL level, you can also add it, which will then help the model to identify. But I wanted to showcase that if you have not yet identified the ASIL level, the system automatically identifies what are the safety relevant artifacts here, and it proposes some of the safety concepts. So here you can see that it has identified some watchdog related functionalities, some E2E mechanisms, etc. And here you can also see the different hardware units. So there are microcontroller functionalities, the clock, the sensor interface functionalities. Oops, I can't see the arrow. Yeah, some power supply units, the interface to driver functions, the flash memory, etc. And finally, the external interfaces like the body control module, the ECS system, the instrumentation cluster, powertrain, radar sensor, LiDAR sensor, etc. So these are the different functionalities when we talk about the functional architecture. Then I have the layered architecture. So from the functional architecture, then you would want to have a visualization of in which layer each of these are. So you can see that in the layered architecture, it has been divided into three main layers. So the software layer, the hardware layer, and the external layer. And inside the software layer, there is also different partition done according to the safety. So you have a separate safety partition where all the safety relevant data can be stored, and the algorithm logic is also stored in a different partition. And this is how the overall layered architecture looks like. And finally, to have a look at the interfaces. So this is about the dynamic part of it. So here you can here you can see that the different interfaces. So now we have identified all the different components. Now, what are the interactions between each of these components? So you have the ACC mode manager. with what all component does it interact with, and what are the different messages. So it can also be seen. So here you can see the different ports, what kind of communication mechanism. So it has a communication to diagnostic manager. Then we have, this is there for all the different functionalities here. So you have all the different components. So you have one for ACC control functions, for the lead detection vehicle, lead vehicle detection. Then you have something for the sensor fusion module, something for the microcontroller, to which all parts the microcontroller needs to communicate with. So it has to activate the communication interface. So we are talking about the CAN-FD here. So there is CAN transceiver which has to be activated. There is hardware watchdog. There are power supply units. There are collision avoidance system, and regarding the RAM. And also we have something related to the safety watchdog, which talks about making sure that it pings the system and make sure the keep alive messages are sent. So this is the detailed architecture views that the tool can provide. Now going back to the use cases, over to you, Alex.
Okay, thanks, Falgun. This was actually really impressive what the tool can offer. So another topic, what I told you earlier, let's say the modern characteristics of architecture. So it should support some kind of consistency check. With that, I mean some cross checks, so that the model can cross check, let's say, coming from the requirement from the input, have a look at, do we have some safety or security constraints? Is the architecture designed to certain design principles? For example, like the modular topic I presented earlier. And if we're having some missing interfaces, for example. So it should be able to see if we have some contradicting dependencies in this case. And this, of course, then support us in having faster review and audit preparation, and also an improved architecture with more quality. So can you show us in the tool if we have something for a consistency verification?
Definitely, Alex. So let me open up a consistency report. So this is the consistency report that the tool generates. So here you can see that overall, I mean, this is a high-level overview. It's an HTML report. Here you can see a small legend. So it tries to detect based on the NPLF ratings, the standard NPLF ratings, and also the SysML stereotypes as well. So here I had, for the sake of the demo purpose, I had checked the syntax part, which is the written syntax, and then the diagram syntax, then the redundancy part, the consistency part, and the safety. So I had disabled the security part, but I just want to mention that it also has security agents which can also check the security compliance. So here you can see these points identified. Now a quick question is, okay, so I'm putting these numbers. So I'm saying that 99.8% of the diagrams are compliant. So what does this mean? So if I click on this, you can see what are the other remaining parts. Yeah, so here. So it talks about the interface view. So before I go to the findings, so what the diagram actually checks, or what the tool actually checks. So it goes through each and every diagram, and it will check the markdown language, and it will check what are the different tags that have been identified. Does it follow the SysML format? Does it have all the blocks identified? Does it have different ports? Is it talking about the initiating port, the receiving port, and the sender port? Are these things identified properly? Are they in line with the requirements that have been defined? These things are also checked. And here you can also see that I think in one of the flow, it said that for the watchdog, there was some error. So it's an invalid type. So this is how you can see the compliance for the draw syntax. Now, apart from that, we also have the syntax for the written requirements. Now, before I jump into this written requirement itself, so let me go back to the tool. Because here you can see, so far we only talked about the diagrams. We just saw the diagrams. We didn't see the written requirements. So here you can see that finally, once all the diagrams are generated, the written requirements are also created by the tool, and it is exported in the form of Excel right now. So this is how the requirement looks like. So here you can see that the basic header stuff is added. This is the first version which was created by the AI itself. you have a view called system overview, which gives a high level overview with the description that we gave about the ECU, high level overview of what the system is about. All these are information. So it's just about, okay, what this what this ACC system is all about. Then for each of the view that we have created, there is a separate sheet. And here you can see the different description. So you can see that the adaptive cruise control shall receive the data from automotive Ethernet component. So there were some LiDAR data with respect to the Ethernet part. You can also see that the ASIL decomposition is also being done here. So you can see if it is a very important signal. So it has added a secondary path to make sure that the single point failure does not occur. So those risks are also identified. So there is a primary path and also a secondary path identified for this. And you have some justification regarding why it thinks it is ASIL B of D and not ASIL D or ASIL C or ASIL B. So these things are also available. Now, having a view about the written requirements, let's go back to the review report. So here we talked about the syntax of the diagram. Now we are talking about the syntax of the written requirement itself. So for this demo, we have chosen the years principle. And here we are trying to see, okay, what are those requirements which have not followed the years principle. So this is also identified and it gives you a justification. This particular requirement is not compliant with the years principle and this is the justification. So this is also given. Moving on, so here you can also see a high-level traceability overview, which we will also have a look at a bit later. I think there was one question from the group which I was seeing. It talked about how does the tool handle conflicting requirements. So as I mentioned over here, so for the conflicting requirements, you can see there is redundancy part over here and also the consistency part. So here there are built-in quality agents which can detect what are the different redundant requirements that are available. So now here I'm only talking about the architecture view, but these quality agents are also deployed so that whenever you add a requirement, when you add the input, so it will also look into each of these items and then see, okay, if there are conflicting requirements or if there are redundant requirements, how do we handle? We take in only some of the requirements, which is important. If it is redundant, we also notify, the tool also notifies the user that these requirements were not considered, which we'll also see in the traceability, and provides the user with the information that okay, these things were not available, because of which either the tool has assumed in our case for the safety part, it has assumed that okay, this would be the safety ASIL level it would add, and along with the justification. Otherwise, if it does not have enough information to assume, then it will provide you with a pointer that okay, you need to provide this information. Perfect. So then maybe we go back to our presentation. Over to you, Alex.
Okay, thanks for also covering this use case. So another aspect what I'm talking about and having a look at the challenges and also the characteristics is that we have many change requests coming into place, and the changes are, let's say, coming in very frequently. So how does your tool help us, let's say, having some smart impact analysis? So if I change something, that the complete chain, what is after the requirement, let's say, is investigated then. So this, of course, helps us to have then faster change evaluation.
Definitely, Alex. So this is also handled in the tool. So here, what you can do is there is also, I mean, of course, I will not be able to show this during the demo, but I can explain the feature. So as and when there is a change in the requirement, so you can re-upload the changes in the requirement. The tool has the capacity to check what was the change that was made in the requirement. It will detect that. From that, there can occur two parts. One, a completely new requirement is added, in which case that will be taken into consideration and the relevant architecture details are added, of course, along with the change request, change ID. The second path is you have changed an existing requirement. Now, in this, if certain things are existing, which were existing has been modified, the tool will check all those data which got modified, and it will try to change or modify the defined architecture which was already created by making sure that it complies to the change requirement. Along with that, you will also have the change ID that will be added so that you know what changes were made in the input because of which the output was changed. Perfect. Going back to the use cases.
Okay, we need to move on to the next slide. There it is. Very good. So another point is that, of course, our architecture needs to be analyzed. So we talk about semantic architecture analysis, so to detect really some duplicates within the architecture, or let's see if we have some overlapping functionalities, and also to have maybe some recommended solution in this case. Is there anything in this tool what can support this statement or this use case?
Definitely, Alex. So again, going back to the tool itself. So as I mentioned, we have different quality agents and different safety agents and architecture agents that are available, that are put in place in the architecture. So there are different passes that are done. So there, let's say in your requirement, you have grouped requirements in terms of chapters. So if it is in terms of chapters, let's say you have some requirements regarding diagnostics, which is available as part of one of the feature, but those requirements probably will repeat in the diagnostic chapter as well. So this could be one. The second would be if it is grouped based on the features, then you would have different set of requirements probably with respect to communication, etc., being written in two different chapters or sections. So in the first pass, let's say the architecture agent will identify based on the requirements the different components, and in the second pass, the quality agent will check what are the duplicate artifacts or the components that are created so that it could be merged. And finally, when it comes to the written requirement itself, we also have, I think I need to go back to the review report, where you can see the redundant requirements as well. So here, the redundant architecture components are also identified, which will also come in the syntax part of the draw.io, and in the written requirements, it will also be identified in the tool. A review report, a compliance report will already be generated based on the architecture that is created. Perfect. Now going back, I think we have one last use case. Over to you, Alex.
Exactly. So the last use case is here to have some optimization part within the architecture. So that our given architecture is then analyzed and maybe optimized to, let's say, some quality attributes or some performance constraints. Also, when it comes to scalability, so to have it scalable. Is it possible in your tool to support also this use case?
Yes, definitely. So I think for the demo version of the tool, I do not have all the parts. I mean, I did show you about the quality attributes. So in the compliance check or the review report, you can see the quality aspects. But regarding the performance constraint, maybe I think I also have something related to the performance constraint. Let me go back to the architecture over here. So here you can see the different RAM and ROM sections. So this has been identified. But when it comes to what is the amount of RAM that needs to be present, what should be the CPU load, what should be the controller that should be chosen. So if you have the microcontroller details that are added in the, let's say, the requirement itself, these can be identified. If not, the tool also has the capacity to provide you such details, like when you have the simulated version, what could be the potential RAM usage, etc. So these could be identified, of course, depending on the functionality itself. If the functionality is not yet complete, then these analysis will also not be complete. Then finally, coming to the suggested improvement about coupling, cohesion, decomposition, and design pattern. So let's say you have design pattern. So every organization have their own version of or the flavor of architecture that they want to build. So they have their own design patterns that they would want to use. This can also be integrated. So in the common workflow, the standard industry design patterns are used. But if you want your organization specific things, you can also add these things into the tool. There are areas and facilities provided for you to add these things so that the architecture will consider all these rules and definitions before generating the architecture items.
Very Perfect. Good. Thanks for that. Mm-hmm.
All right, so I think there was also one question regarding my next topic. So do you have plans for generation of test cases against architecture, generation architecture design? In short, yes, there is. So the tool already has the capacity to do it, but today, since we are talking about the system architecture, so we are focusing on the system architecture demo. So to give a brief overview of what the tool is capable of. So there are three main focus areas. So this we also saw when I opened up the tool. So there were three main ideas. So the compliance, generation, and elicitation. So we have the requirement elicitation that is available, where you have the stakeholder requirement and then you can elicitate the requirement. In the generation part, we have the engineering work products and process work products. The tool right now is mature enough to generate requirements, system, software, hardware, generate architecture, system, software, hardware again, test specifications, so system test specification, software test specification, hardware test specifications. These are some of the things that is the tool is currently equipped to handle right now. And of course, when you're talking about the compliance, we saw the review reports that it generated. To give a quick overview about the architecture, so this is a very high level architecture. Giving respect to the time that we have, I think we have another 11 minutes. I also want to keep some time for the questions. So the left side shows the environment of the complete, the development environment. It can be anything. For the sake of simplicity, I have added just some of the standard tools like IBM Doors, Polarian, Subversion, etc. Of course, it can be anything. Right now, at the standard tool, it exports, it accepts of input in 2-3 formats: ARXML file, Word, Excel, PDF. But if you want to have a customization, of course, this is also possible, where you can connect, we can expose some APIs and we can connect directly to the existing tool base itself. Now, in the carAISuite tool itself, there are two layers. One is the interface layer and the other one is the backend layer. In the interface layer, as you saw when you upload the document, the different understanding of the document, the chunking, creating the models, creating the different graphs, these things happen. Once these things are completed, then the tool, the data is given to the backend model, which is a fine-tuned LLM, and where all the things happen, the architecture generation happens. Of course, we have different agents to do different tasks, and once the output is finally generated, the post-processing happens. In the post-processing, there are 2-3 steps: creation of the diagram, making sure that the diagrams are explained in the Excel sheet, putting that in the right column along with the traceability, etc. And finally, also creating the review report. So these things are created and the output is generated in the Excel format and the HTML export, which can then be directly imported into any of your tools, or if we do a customization, it can be integrated. One quick note, you can see that we support two options. One is on-premise and private cloud solution. On-premise, if your infrastructure supports, everything can be hosted, no quick questions, no second questions on the data protection. But if it is private cloud solution, for any reason you don't have the infrastructure, we have a dedicated private cloud, so we can host either in your Microsoft cloud, Google Cloud, Amazon Cloud, and we can work with these models. Over to you, Alex.
Yes. So Falcon, you already mentioned that your tool, let's say, would like to be compliant to Automotive SPICE. So that's why I picked here Automotive SPICE as a kind of a reference. And let's see what is required by Automotive SPICE for the system architectural design. So we have an own process for that. It's called the SysFree. And we also then have it also on software level and also on hardware. But here we talk about the system level. And I just want to briefly explain what is expected by Automotive SPICE. So the purpose itself tells us that we would like to have an analyzed system architecture having static and dynamic aspects. And it should be, of course, consistent with the system requirements. So we need the system requirements as an input to generate our system architecture in this case. In the overview picture, you see we have 5 base practices covered in Automotive SPICE 4.0 version. So it starts with having the static architecture developed. So this is, let's say, the hierarchy view and also, let's say, the functional breakdown. And then we have some base practice 2 is then to have the dynamic architecture in place. So here we talk about more operating modes, some state machines, some sequence diagrams, some activity diagrams to have in place. Then, of course, we need to analyze the architecture. So analyze, it's always a big part in Automotive SPICE. Then to ensure if it's consistent and traceable to the system requirement in this case. And to communicate the architecture. And just having some key aspects of Automotive SPICE for this process. So in other words, we need to have that the architecture provides a static and dynamic aspect, or dynamic view, let's call it. So this should be in place. So the architecture needs to be analyzed. And with your tool, I already saw that you have several, let's say, architecture or analysis methods in place. Well known is the FMEA in this case, but of course you can have also other analysis parts. This helps you then later on having some design decisions documented. So you can do some prepare or comparison of different architectures. Again, traceability, consistency needs to be ensured, and the communication needs to be in place. So these are the requirements out of Automotive SPICE for a system architecture.
Perfect. All right. So then I think time to maybe I'll come to this a bit later. So let's quickly take up some questions. In the meantime, I tried to answer some of the questions. So for whatever I have answered, I think I will not go back to that. Then the other ones we can have a look. I think Dennis had a question: how do you handle changes? Is it able to baseline the requirement, design baselines on input changes to requirements, and then generate updated architecture with minimal impact? Yes, Dennis, we have the different agents which detect the changes in the input. For the baseline part, if you are maintaining the requirements and the architecture in the tool itself, yes, the baseline part is available where it can provide you the changed version, and you can also compare between the changes as well. I'll also come back to this point because I have a small feature update on this topic as well. Then does it also capture rationale for design decisions and definition? Yes, for all the blocks, for every input that has been given, the rationale will be there, the justifications will be provided, and this will also be available. Garrett had a question regarding hallucination. Okay, how do you handle hallucination? Yes. So Garrett, quick update. So whenever we talk about AI models, of course, hallucination is a big topic. What we also do is we have evaluation matrices in place. So these are the different agents that we have. So in our current evaluation matrix, we have the RAGAS matrix to make sure that the tool is not, it's not giving you hallucinated output. Apart from that, the control given to the large language models are quite less. Most of the other works are being done by different agents. And we also use multiple agents to make sure that if one part of the tool has hallucinates, then the other part of the tool can check and make sure that these things are reverted back, and then it could be minimized to the lowest level. Okay, then another question is it able to handle generate? Okay, dynamic diagram. Yes. So we also, I mean, for the sake of the demo, we created only 4 architecture elements, but the dynamic architecture like sequence diagrams, the state flow diagrams, the transition diagrams, the tool is able to also handle these things, because this also becomes very important when you're talking about the software architecture. So the tool also has the capacity to build up all these things as well. Okay, so I think we have just 3 more minutes, so maybe I'll take one other question. So is this tool a plug and play solution ready for immediate use? I think I picked a fantastic question for my transition to the next slide as well. So this is a sneak peek of the future. What do we have? So you saw that I showed a demo of desktop-based application. Now, of course, you would all want to try this as well and then find out for yourself what kind of inputs, if you give, what output it generates. Current situation, of course, it is not possible. What we are also trying to do is we are trying to come up with these web version of the tool, which is a private cloud version of the tool. So this is a high-level look about the web version of the tool. I will also show you how it looks like in a quick view. So this is how it looks like. And I just have to log in. It'll ask me for an OTP, and I just get the OTP. I add it, then you come and land on this dashboard. So here you can, oops, I think I got timed out. Yeah, so here you can see the different boxes here. So you can see it supports requirement station, requirement generation, architecture generation, test case generation, the compliance check. You can also add your credits here if you are running out of credits, and then you can see the projects. So let's say you have a particular project. This was one of the projects for the requirement station. You can see how the requirements are viewed, what are the different attributes it fills. You can have a quick look at the insights as well. So this gives you a high level overview of your tools details as well. And here you can also maintain the baselines. The different versions are also showed. If you want to re-upload certain things, that can also be done. So this is a quick sneak peek about the web app that is coming in. So of course, the next obvious question all of you might have is when can you access this? This will be out in the month of June. So probably in the next couple of weeks, maybe 2 to 3 weeks, it will be available. So if you want early access to this tool, please do sign up for this tool, and you will also get an early access for this. You can also have use this, play around a bit, and then look into how the tool works for you. Perfect. Alex, final thoughts from your side.
So thank you for this very good live demo. I was really impressed what the tool can offer, and that it really covers all the AI use cases. So I'm curious how, Falgun, how you will develop it over time and what kind of features you will integrate into that tool. So of course we're going to stay in touch and yeah, share the knowledge.
Definitely. So, thank you so much, Alex.
Thanks for inviting me. Yeah.
Perfect. Thank you so much for also enlightening us with the history and the do's and don'ts about the architecture, what the standard says. And we were very happy to have you. And thank you so much for all the participants who joined today. And I hope we were able to give you an insightful session with the system architecture along with the demo and the theoretical knowledge. Stay tuned to get more access to the latest features as well. And I think probably in some time, or maybe by tomorrow, you will also have the slide deck available to all of you, whoever attended the webinar, so that you can also go through these slide decks. And of course, feel free to sign up for the AI tool, the web version of the tool, so that you can have your requirements or architecture. You can play around with the tool and then enjoy the tool and use it to the maximum benefit. Have a nice rest of the day, start of the day, end of the day, from the different parts of the world. Thank you so much for joining. See you guys.
Thank you very much.